So in the last video, I trained the linear regression model, and I told you that this is the weight and bias of the model. We can use this information and reproduce the prediction result in the Excel file. Here. Okay, let's just try this. Let's split the data. It's all Korean, but it's you can use it in the data tab, and there's an option for separating the data, and using the space I can simply split these values. So these are the weights, and let's save my prediction. And we have a bias. This is the bias. Oop. And this is the bias. So my model's prediction is this times this value plus this times this weight, and this descriptor times this weight, and then this descriptor times this weight, and this descriptor times this weight, this descriptor times this, and then bias. So this is a prediction of my model, and weight should be fixed. And then I'm gonna make a prediction for all the data set here, all the compounds, using the this descriptor values. So I just double click it, and then this is the result. So how do I know this is my prediction? Let's compare it. So you see the first value is 7.320867, same. This one and this value are the same, and these are the same. These and these are the same. So you see, they're just same. So I can confirm these are the weights of the model. And the next thing I want to confirm is this score. So score, I said it's r squared. And how do I know? I just compare it with here. So in scikit-learn, there's a separate method to calculate r square. So in this case, test set's score was 0.869, and if you use r square score, you get the same result. So the basically score in the model are r square value, but we also use different matrix. But mostly the models with the highest r square also have lowest RMSE. Well, not true all the time, but mostly they have a strong correlation. When it goes up, it goes down. So RMS is a root mean squared error. So yeah, you can calculate it in using this method. But there's a saying in the literature that if r square on the external test set is higher than 0.6, then the model is quite accurate. So that has been the standard to check it. But if the model's r square on test set is lower than 0.6, model still can be used if the model can't make a good prediction for most of the data set. And how do we know? We know it through the normalized RMSE. So here RMSE itself tells us nothing, because RMSE scale of the RMSE values are changing. If the range of the endpoint is larger, RMSE is also increasing. For example, there's a case of melting point prediction model. So in that data set, melting point has a higher scale. Like the last time when I work, the data set I had was ranged like a lowest value is like a minus 100 Celsius degree, and the largest one was like a 4,900. So in this case, model normally have a larger RMSE, like RMSE value is hundreds, but that doesn't mean the model is inaccurate, because the scale of the endpoints was just bigger than these. Here, PLC50 is in low scale, so it's normal that the RMS is quite low. But how low is it? So to check it, we use this. So it's called the normalized RMSE, and RMSE value is divided by the range of the endpoint, which is the maximum value and the mean value, times 100. I just put the maximum value of the test set and the minimum value, but you can do that with the training maximum and minimum value of the training set, and to be more robust. But the point here is that if here the normalized RMSE times 100 should be less than 10%. So based on the range of the endpoint, the RMSE value is confirmed, and if the RMSE is lower than 10% of the entire endpoint range, then the model is quite accurate. So even though R squared is not good enough, and this normalized RMSE is less than 10%, this model can still be used to make the prediction, because it can make a good prediction for most of the compounds. So that's how different metrics are used in the model. So when you develop the model, you need to use more than one metric to evaluate the accuracy of the prediction model. And the one last point here, round function is used to round up the value to make the value is much more nicer. So that's it.